Hi folks, Bill Steele here with 3DChameleon, and in this video we're going to cover the software installation for the new Mark II 4-color 3DChameleon. And in this case, what we're going to do is we're going to look at the PrusaSlicer configuration and how we set it up to target our particular machine. So to start off with, if you scroll down here to the bottom, you'll see that there is a video linked in here. You can actually click on the YouTube link for that. And in the YouTube link for that, you can scroll down here to the PrusaSlicer profile used. We're going to hit download on that. And if it opens up to this rotating flat cube, then you downloaded the right file. We're just going to go ahead and click download for that. And that's going to save that onto your machine. The next thing that we're going to do is we're going to run PrusaSlicer. Now I am running the latest version of PrusaSlicer, PrusaSlicer 2.3. And this is as of, well, the date on this video is February 7th of 2021. But what we're going to do is we're going to go ahead and do a file open. And we're going to open up that file I just downloaded, the BMG test file. And if we want to, we can immediately hit slice, and voila, we now have a 4-color sliced object. So there was no changes necessary to actually get that to work. However, that depends on that your button is actually in the exact same location that the button was on this particular machine, which happens to be a Anycubic Mega 0 with the BMG extruder, or I should say BMG clone extruder. If you wanted to load in different models, you can actually just delete these models and just simply add new models to it. So whatever they happen to be, here's 4 mountains. Let's open that up. We'll say yes, this is a single part object, and you'll notice that it's assigned different colors to each one. If I slice it right now, we'll get 4 different colors, though they might not be the right colors for this particular object. In fact, they're not. Maybe on Mars or something like that, they look pretty good, but anyway, so that's a 4-color object that we've just loaded in. You'll notice this one's actually complaining about an empty layer, so one of the layers does not appear to be lined up correctly with the others. So you want to check that. In fact, there you can see that. You can see that white layer is up just a little shade too high. Let's go ahead and see if we can identify that fault real quick. If you look very carefully, you can see that line across there. And that's telling me that that top object, the white one, is not exactly where it needs to be. So let's go ahead and lower that just a little bit. We'll make it 3.9 millimeters. And then we'll reslice that. Let's see if that empty layer warning goes away. Yeah, there you go. So something to be careful of there. That was just a 100 microns lower allowed it to line up correctly. Interesting little flaw in the model. That was simply downloaded from prusaprinters.org, that model. So anyway, back over to what we were talking about. In this case, I've loaded in the file. I'm using these configurations from this BMG test1.3mf file, but I really want to save these to my machine. I want to use those on my machine as if they were stored settings. So I'm going to store those simply by hitting the save icon here, and I'm going to give them a new local name. So let's actually just give it the name that I have already in there. And we'll do the same thing for the printer settings. Okay, and then we also have filament settings. Let me go ahead and save that. Actually, that's just a generic PLA, so I'm not even going to worry about that. We can actually switch to whatever filaments we want to. You notice I have some temperatures already set in here. The flow rate, extrusion multiplier, things like that. Those are already set. So with that set, those settings are now stored on this printer. You can ignore this one, even though these are here. Once you reboot PrusaSlicer, you will only see the ones that are actually saved. And what this will allow you to do is if you exit PrusaSlicer Actually, let's just go ahead and do that. We'll just relaunch PrusaSlicer. And we'll just add our new file. I had those mountains before. Let's go ahead and open those back up. Yes. And again, we're going to get the same error here because that first one is a little bit off. So let's change that to 3.9. And now we should be able to slice that just fine. Get some colors loaded here in a second. There we go. So there's our file. And what I was talking about was when we do this, we save these. You'll notice that 3MF version of the file went away. Same thing with the printer settings. We now have a setting configurations settings stored on this machine that you can use for any other files that you want. So that's how you set the software up from that standpoint. Now, with that said, we do need to tell the printer where to tell the slicer where to have the button in the G-code. So when we look at our profile here, the only things that we've really changed from the default settings for the printer are that we've told it that there are 4 extruders and that we are using a single extruder multi-material setting here. And that creates the 4 extruders. These are all your stock extruders, so there's no need to modify any of these, except maybe the color that you want associated with each one of them. You can see that here as I go through here. That lets me pick a new color for each one of those. But none of the other changes, none of the other settings need to be changed. What we do in the 3DChameleon, though, is we actually have a custom tool change G-code. You do not need to modify the start or the end G-code, even though we did just for a little bit, messaging. But there's no functional differences in any of this code here. But what we did do is we added all of this code here, this tool change G-code. This tells the slicer how to inject certain amounts of certain bits of code into the G-code stream going to the printer to tell it how to get to the button, tell it which button sequences to press to switch to the various colors. Now, in your most basic configuration, if you install the 3DChameleon button on either the X or the Y axis, all you need to do is tell it the initial location. Now, this initial location is literally moving the print head or the build plate close to the button. And in fact, by default, it's 3 millimeters away from the button. By moving it 3 millimeters away from the button, the rest of the code knows how to move to press the button. You'll notice that what we do to press a button here is we issue a go to command and we tell it move an additional 3 millimeters on the X and the Y axis. Wait, that'll actually press the button. Then we wait for a certain amount of time, and then we move back off the button that exact same amount. And then we wait for whatever that sequence is to happen. And you'll see that this is all over this code. We do that everywhere. It's always moving 3 millimeters to engage the button, and then 3 millimeters to move back away from it. And we do that at a relatively high speed of 2,000, sorry, which should move the printer as fast as it can, press the button, and then move away. That makes all of our timing sequences pretty accurate. In an advanced configuration, you might need to tune these P values or these S values. Look for the G4 commands, depending on where you're at in the sequence. This is 3P indicates this is in milliseconds. So this is pressing the button and waiting for 300 milliseconds and then moving back off of the button. And then S is actually in full seconds. So in this case, it's waiting an additional 1 second for that sequence to occur. And you'll see that that's what we do everywhere inside of here. If you have any questions about this, or if you see that the sequence is not actually doing what you think it should be doing, feel free to give me, send me an email, bill@3dchameleon, and I'll help you edit this or do whatever it is you need to do to fix that. But generally, there's only 3 parameters that you need to adjust whenever you're setting up the 3DChameleon. And this first one is the most important. It's the location of where your button is, minus 3 millimeters. So for example, if you placed your button on the end of the x-axis, what you're going to do is you're simply going to home your printer and then manually using the LCD control, move that axis, move the x-axis over until you see the hot end press the button. It's going to press it at some certain value, maybe 213 or 212 millimeters, or depending on your machine, it could be 180 millimeters, it could be 300 millimeters. That's totally dependent on the size of your machine and where you've placed the button. You're going to take whatever value that happens to be. If you put it on the x-axis, you're going to put that value here, minus 3 millimeters. So that's the important thing. It's always going to be minus 3 millimeters because the rest of our code will always move 3 millimeters further to engage the button. And then the same thing is true as if you put the button on the y-axis. You're going to move the y-axis to that, again, 180 minus 3. So it might be 177 on a Prusa Mini, for example. So you'll see in this video that we actually moved it to the y-axis on the, not in this video, in the video I just mentioned. We actually placed the button on the front of the y-axis, and that happened to be like 212 millimeters. So you would put in 209, for example, here, 3 millimeters less on the y-axis. Now the other axis is always going to be just the middle of the travel range. So in this particular case, I have y of 110. That means that this printer actually has 220 millimeters on the y-axis. We just divide it in half. That puts the nozzle right in the middle of the build plate. So what's going to happen here is when it's printing, when it wants to go change the colors, it's going to move over here to the middle of the build plate. Okay, that's on the, I'm sorry, on the y-axis, it would move it over to here, right? On the x-axis, it would move it over here because that's saying the button is over here or the button is over here. And technically, it's actually going to be on the front on the y-axis. So the button is over here in the middle or the button is over here on the x-axis. We just want the nozzle right in the middle of this purge block, right? So basically, we're going to move it past it. And the idea here is that when you're loading filament, a little bit might dribble out. And what you want to do, you want the nozzle to sit over here on the side so that if it does dribble out, when it moves back to continue printing, it's going to move on this side of the purge block, and the purge block is going to wipe that off. That way there's no dribbles or stuff between the part and the purge block. So always place your purge block between your part and your button, wherever your button happens to be placed. So back over to our code here, you're going to adjust this value here to basically push the nozzle over to that location, right? So that's all we're doing. We're moving the nozzle over to that location, and that's indicating that the button is going to be 3 millimeters farther away. Okay, so it's going to move 3 millimeters. If you put it on the front, it's going to be 3 millimeters farther than the front. Okay, that's all we're doing. We're just simply moving that nozzle so that it is out of the way, past the purge block, and 3 millimeters short of the button. And our code then does the rest. Now there is one other parameter that you're going to change, and that is going to be the time that it takes for the filament to load or unload from the tubes. So once you've loaded it into your extruder or unloaded it from your extruder, you need to actually indicate how far, I said one parameter, there's two other parameters. One is going to be how far you unload it from your extruder. That's going to be this block of code right here. Retract it back out to the Y adapter, or this should say to the Y adapter. This is actually going to pull it out of your hot end and eject it from your extruder. Okay. This distance happens to be 380 millimeters by default, but it could be any value, any distance. The idea is that you have a PTFE tube that goes from your hot end to your extruder, or you might not have one. For example, you have a Prusa Mark III. There is no, long distance there, so you don't need to back it out 380 millimeters. You might only need to back it out 100 millimeters or 90 millimeters. The idea here is that these values add up. This minus 100, minus 100, minus 100, and minus 80. That's minus 380 millimeters of motion. Marlin, the firmware that most printers are based on, does not allow you to move more than 100 millimeters at a time. So these blocks of code are just simply moving it 100 millimeters at a maximum at a time. And then we reset the extruder back to 0. We tell it it's back at 0. Okay. So by doing this way, you can add or remove any number of length, 100 millimeter lengths that you need to get yours to unload, and then any additional film motion that you want it to go. So in this case, we're traveling 380 millimeters. It could have just as easily been 400. Maybe 350 wasn't enough to pull it all the way out of the extruder. You want to make sure that whatever value you have in here is enough to pull it completely out of the extruder. If you have a flash forge machine or you have a Prusa Mark III, this might only be 100 millimeters, just one of these. So you don't need the rest of these. You can actually just change this last one to 100, like that, and you can delete the rest of them. So I would comment them out just to begin with, right? The idea there is that you now only are backing it out 100 millimeters, or maybe 90 millimeters is enough to clear your hot end or your extruder. So that's what you would set that to. So likewise, later on, where we are actually setting it up to unload this distance, we're also going to load this distance. Okay, so down below here, this is the counter to unloading it. We're going to do a load. Reload filament all the way into the extruder. This is after it has been unloaded, changed, and then presented back to your stock extruder. Now we're going to reload it. This is going to load 350 millimeters, and you're going to adjust this last value to get it to right where your nozzle is, right? You're going to increase it or decrease it. We went 380 before because that ensures that we've pushed it past the extruder as far as we can go, and we went 30 millimeters extra. But in reality, you don't want to load 30 millimeters extra because then you're going to be squirting out filament. And you're going to adjust this value to compensate for that. Just going to dial it up or down to match exactly what your length is. Again, if you're going to go over 100 millimeters or need to remove 100 millimeters, you're going to either comment these out or you're going to copy and paste another set of this in. It just happens to be that all of these have to add up to whatever the distance is from your extruder, your drive gear in your extruder, to the tip of the nozzle. That's the distance that you need to measure. And I'll have a video shortly to show you a very quick way of finding out what that value is. Okay, so that's the second parameter that needs to change. Now the third parameter that needs to change is the time. Once we've unloaded it from the extruder, the 3DChameleon needs to know how long to press the button to move the filament out, let it change the code, and then move the filament back to the, and by default, we're typically going to use this at around 7 seconds. Okay, you might change this up to 8 seconds, that's okay. You might change it to 6 seconds. Maybe yours is a shorter path. I don't recommend actually going that short. I think 7.5 should be good enough to pull the filament all the way out of the Y adapter and allow you to insert the new filament in. If you want it to be safe, you could actually just go to 8 seconds or 9 seconds or 10. This depends on how far you want to pull it out. But in general, we found that 7 seconds is enough to do that. Now, I like to keep this in an even number of seconds. You can actually make it in milliseconds if you wanted to. So, for example, later on when we're actually reloading it, we are actually doing it in milliseconds because we're adding 500 milliseconds to the end of that time frame. So in this case, the G4 7500, we're increasing that value to, we unloaded at 7 seconds, but we're reloading at 7.5 seconds. That ensures that we're driving it into your machine's extruder and that we can get past the drive gears for a little bit. And then once we do that, we then loaded up an additional 50 millimeters into the system. And then, again, you can also adjust this value as well. This is basically just saying, okay, now that the 3DChameleon has pushed the filament into your stock printer's extruder, how far in addition do you want it to load it? And in this case, we loaded a half a second plus 50 millimeters. So you don't necessarily need to go that far, but this works just fine. So really, those are the only values that you need to adjust. There's three basic ones. The first one is the most important. Where is the button located? The second one is how long is the tube that you're unloading? How long is your from your extruder to your tip? Okay, and we added, in this case, 30 millimeters extra to it just to make sure we got enough out. We then changed down below the reloading of this same thing. So we pulled the filament out, and we also need to have the same distance to push it back in. That's what the 350 down below was. And then lastly is how long are we pressing the button? How long are we telling the 3DChameleon in seconds to unload from your extruder back through the Y adapter, and then again, how long to reload that. Those are the only values that need to change. So in the next video, we're going to go ahead and walk through these values, these settings on the particular machine. You'll see how this is configured and how you can adjust it for your particular machine.